Sure. I'll send this discussion, guys. It's also no worries on it. As long as you update, it should be good itself. So take a look at it. In fact, in the HDFS thing itself now, if you just do a browse itself, and in the big data folder, this is in HDFS folder, I uploaded a 195 MB file. Now this is something way more than the other default that it uses the 128 part of it. So this is something which we uploaded using the common copy from local or the put command, and as you can see that the block size, the default one which it is using here is 64, and deliberately we have kept the replication as one. We have not specified multiple different replications to it. So if you try to now do a health check on this particular part itself, let's see if the Hadoop system is running in GPS. We'll do a bin slash Hadoop DFS admin. Sorry, DFS admin will not give. Just add DFS admin and go for the report section. Oh, where are we? Oh, sorry. Home, Oracle, Hadoop install. Okay. Bin slash Hadoop DFS admin hyphen report. This will just do a scan. You can see this gives a detail of the current HDFS file system from a name node perspective as well as the data node perspective. But we know that the 195 MB data, if it has to be stored, it should result in 4 different blocks itself, because 64, I think that's the basic unit it is putting in. Now to look into that level of detail, that how many blocks actually it has split it up and all, let's run the file system check command, and we'll specify the directory which we want to access the data in. This is the slash big data directory available. Take a look at it now. It's again, many of you, if you try to do it on your virtual machine, might run out of space. So please, I'll say, make sure that in your Oracle home you have sufficient space available and all. The default space which this virtual machine gets allocated is less itself, so you might have to add some more media to increase the space. But if you have created your own VM, or if you have a standalone Linux box or a Mac, then it should not be an issue. Whichever is the directory you specify for data, it should be good. But take a look at it. This is where it tells you the details of this particular data file, the big data. If you look into it, it is in the slash big data. This file XAA was there, and in this one it gets split into 4 different blocks, because again we know that this is not, all these 4 blocks are not completely occupied. 3 of which are, but there is one which is under occupied. It just doesn't falls in the multiple of 1/64. But yes, it does shows you the number of blocks that are available, and all of them are minimally replicated once, because that's the default criteria it uses. Since, and again in this one, since it's a quasi custom mode, we have kept the replication factor to 1 to save the space and all. That's where it puts in. So it shows the detail. Now let's try to run it and map reduce job and try to take a look at it. So we will use the word count which already comes in and try to run with this particular data, how much data set it generates and the map that it triggers and all. So if you try to run, let's go back. So accordingly, as if you keep on increasing the size of the data part itself, you can see through the file system check commands the number of blocks that gets split it up, and in that particular it's puts in. So if you try to run the, suppose Hadoop DFS sorry, jar Hadoop-examples word count, and we'll specify now the big data as the folder where it has to pick up, and some output directory. Let's see what is not available. Home development. Okay, I'll say here I'll just put test output /o1. This is the place we'll try to store the data in. Yes, okay, I didn't tell you guys this. So this XAA file which you are saying is a pure text file itself. So this is the same a large book from your project Gutenberg itself. Multiple times just added the book and try to create a bigger copy of it. It's the text content itself. It's just that the file size only has been increased up. So in this case, like, okay, let's parallelly open our MapReduce framework also, and then we'll kickstart this process. Now this will start processing that particular part. Let's try to run this up. What happened? Okay, it does start. Let's try to monitor it visually itself, see if it creates a specific job. Give it some time. It's at least from a current capability that this VM has, will take some time for it to refresh and show you the detail. Yep, it's coming in. Now this is a large file compared to the type of capacity this particular processes can handle on a single VM. So it will show you the progress gradually. It's just that it takes some time to refresh and get that detail, because this is a more I'll say comprehensive load compared to the 4 MB or that type of stuff that you have been working on. I think here it just shows, you can see the progress. It's no longer in that multiples which it was like 3360 and then done. It's really using the different resources. So let it complete, and we'll also have to keep an eye on the space that we have, because the only way it will just default to an issue is if we ran out of the space between. So let's take a look at it. So we have 21.91. So again, this will keep on falling if you refresh it, because it's trying to write it up and execute the same, but I think that should be sufficient to handle this volume this time. You'll have to give it some time, and as I said, that when you practice it, just take a static load, and this is one I'll say a good sample size for you to benchmark, or at least get a comprehensive data for your streaming job, the one that we practiced yesterday. Try to practice it for the core. Use this data set and first try to use it for the 4 MB part, which is a smaller data set, and then try to do it for this large data set and see the benchmark that comes in. We have a question here that so to recall earlier, the higher the replication, the better is the performance. Well, I don't agree with that. The replication is for your data contingency, in the sense that if one particular thing get corrupted, it's like more for a data security part itself, that if you lose one data or a node or get corrupted, you will get access to it. So making multiple replications will not directly impact your performance. If you make multiple replicas, it will occupy more space on your system, and it will make the system more robust in terms of recovery and all, but it does not have any direct impact on the performance, because at a time when your MapReduce is running, it will refer to one working copy of the data. So in this case, if you do saw that this file, the one 90 MB file, it is having only one replica spread in 4 blocks. Now if I change the replication factor to 2, although in single clausy cluster mode it will not entertain that, but if you run it on a multi-cluster and then change it to 2, it will end up creating 4 blocks, 4 more blocks, so total of 8 blocks and all. But when you are running the map reduce, even in that mode, it will refer to 4 blocks only at a time, so it will not directly impact the performance. Give it some time. Let me know in the meantime if you have any questions. Just put me in the ping box. It's because I can enter in this will take some time, but we'll just try to analyze. But one thing, as I requested, try to because you already run this simple program for a lower volume size, but for this 200 MB, try to run even the streaming example, the PHP script that we wrote, and try to get a feel of how much is the difference that is coming in. We'll now try to, after this run, we'll try to like put it or add multiple reducers to it and try to see that how much of that impact it will have. Because many times if you define too many reducers, again, since this data has to be split across multiple of them and individually each of them is writing in, you can take a look and see the impact of how it's doing on. Mr. Anand, I'll just unmute you if you can reiterate your question. I think I didn't understand if you have replication copies, it read parallelly from the copies. So if you can specify.
Right. Right. If you have like 3 multiple copies of replication of the same data, while it is reading the information, it reads parallelly from all the 3 nodes. That's what the throughput will be increased. So I read one of the documents somewhere, but I'm not sure. That's what the understanding.
No, see, it does read all the 3, but all these 3 are 3 distinct parts of the data, not the same part. So again, in this case, the file which we have, like, it is spread into 4 blocks. So if these 4 blocks happen to be stored on 4 different nodes, it will try to read it simultaneously from all those 4 nodes, because that's what gives it an efficiency, and that's what this parallel infrastructure helps it out. So of course,
Right. But if the same copy, I mean like the same block, if it is multiple stored in the 3 nodes, it read parallelly the same the copy, not like the new one. Like if you have like one block replicated to the 3 nodes, while it is reading, it reads from the 3 blocks simultaneously, so that the throughput will be more. It's not like reading from any one of the node. Is it true? Just it's not my.
No, that's not my understanding. My understanding is that it tries to read the one, because these blocks are again distributed on different nodes itself and on the slave boxes. So it tries to access the block from the node which is the closest possible one. That's what it tries to put in. So if you have these nodes across different data centers in different racks, so you have now a complicated rack type of structures, wherein in one rack server you have multiple nodes. So it tries to read first the data from the local node in which the master, job tracker and the slave nodes are available. If it is not able to find any block on its local rack, it will try to access the other rack to get the data. But the principle of closest proximity works, and Hadoop nodes are, or Hadoop processes are rack aware, so they know that these are the nodes in one rack compared to the other ones. Okay, I'll unmute you, Mr. Matt.
Okay.
that's something I think. Go ahead, Mr. Masood. Go ahead, Mr. Masood. In fact, I unmuted you, so you can just put in your comments.
Oh, sorry, I was speaking, but I was not unmuted on my side myself. Anyway, so I was experimenting with my setup. I set up one master and one slave cluster. And when the MapReduce job was running, it did launch some map jobs, and there is also a status, if you see on a job status, even in history, failed / killed, okay? And my failed were 0, but it killed 1 or 2 map jobs once in a while. So felt for me like, it was giving task to vacant cluster, vacant node, so that whoever comes first, it will try to, come in that data to give to reduce stuff, something like that. So that's where I thought maybe replication factor, at least as many as the number of nodes might help improve the
Actually, in that sense, yes. So again, that is a scenario where your speculative execution is taking place. But that is a place where, again, so of course it must have retried it, that if one particular slave is taking a longer time, it will rather give the same job to the other slave where there is a replicated copy available, so that again it's local to that particular node for processing. And if that happens to complete it fast, of course then it adds the performance, but it's not directly related to your performance criteria. Only in a situation where
if you can pull up one of your history MapReduce job, I just want to show you one of the column value there.
Okay,
let's pull up something that is already run. Just click on any job there.
Yeah.
So see the last column on the right, failed / killed on the top, about top. Yeah, see, failed / killed task attempts. So on the map, I used to have something like 0 failed, but 1 killed at a time, but most of the time both 0, just like you have here. Yes. So it was trying to give task to the second slave node that I had. So I did set up my multiple cluster thing. So that's where I struck me if replication has anything to do with that.
It does.
I had a replication factor of 2.
Okay, no, that must definitely have helped it out. It's just that it's not directly related to your performance, but yes, if speculative your execution is on, which you open it through your map rate setting, if that's the way your job tracker is executing the job, of course it will try to find the next node where a local copy is replicated, and then it will try to re-give the same task to that node. So it definitely can help it out. Of course, again, that's what said that many of these complexity would get settled, or when you do an actual, I'll say, multi-node cluster type of thing. But from a process perspective, the coordination and the difference, it's pretty much visible even in the quasi-cluster. But yeah, things like this one, low level, your data replication impacts, as well as you saw the kill part and all that is coming in, they are not going to be visible on a single cluster part. They will get visible only when you have a real-time multi-node architecture available.
And I have one other different question. We can discuss in detail later if you have time. But basically, along with my multi-cluster setup, I wanted to experiment decommissioning one of the node. When I try to decommission my slave, it took the whole night. Still it was trying to replicate the blocks to under replicated blocks sort of thing. So the job ran for the whole night. Then I read somewhere there is some attribute which might increase the interval of replication data amount or anything like that. But I didn't want to experiment on that. But
no, but you are trying to replicate. See, as I understand, you have a master and a slave, 2-node architecture, and if in that one, if you try to replicate, then all the load has to come on a single box. So this I'll say is not a very ideal candidate for a replication, because what is happening is that now on your master system all that replication data is coming in, and I think if you have kept the replication to 2 on, if it's going to be just one node cluster, I don't find a good reason why it is trying to replicate 2 copies on one, because then essentially it's becoming a quasi cluster mode installation when one particular dedicated slave is going out. So that might be complicating the picture. So if you take a look at it, at least if I have minimum 2 nodes, 2 slave and 1 master, then it will make sense, because it's still a multi-clustered wherein now the data is replicated from one node to the other node and all. But in this case, your single slave was going out. So now everything is getting copied on your master process, and I'm not sure when you have configured your master and slave, are you running your slave master also as a data node?
I didn't have too big a data there. I had only your Gutenberg project that you gave me. I just maintained that 8 copies. I had
No, but are you running your processes on the master itself? Because remember, if you configure it, so your
I was
data
not running anything. I use my master only for the running processes. Master, as well as I stood up another virtual machine. I set up network, everything. All those happy path scenarios are in place. So
okay.
if I was monitoring the log also, it was trying to replicate under replicated blocks since the slave was it was still decommissioning overnight, even when I checked just before I joined your class. So I can share the log, and I can show you what was going on. But basically saying by the default settings, decommissioning is very slow. I read somewhere on the internet as well. Maybe it's something with this version. Maybe they have something covered in the future one. But if you tweak some values, temporarily, the decommissioning can happen quickly. Otherwise, decommissioning is really slow. That's what I have.
That's again, anyway, it's not a priority process for it. So it happens keeping into consideration all the current map reduce functionalities. So it happens in the background itself. But as I said, that if you have a more logical multi-machine cluster, I think it will be a more replicated scenario. But yes, that something can be seen, that why is it taking that much time itself, because it must be complaining. At least the processes might be timing out, or the replication factor needs to be tweaked in bare minimum 1. So all those parameters may need to be configured now.
Yeah. So then I aborted the process of decommissioning by removing the slave nodes from the exclude file, and I just ran the refresh nodes command, and it stopped decommissioning. It's now it's back to whatever the full cluster setup.
Okay. So it will just put that particular thing. Let's see if this job completed. Seems to take a hell lot of time. What's the timestamp? We can check it out for. Just give it a minute. The 24th. Yep, this is, I think, is the 1/17/24th. Yep. So this is where you see that it did run. It took around 9 minutes and all. Again, this is because of this system itself. But if you run other parts itself, parallelly try to run the Python based scripts also with the same data set, and just try to see how much time difference you get. And that's probably a good way to start benchmarking. Your core Java should dominate. That's at least the optimization that most of the people see it. But again, it depends on the type of complexity that's getting executed in your map and reduce jobs. Okay, and as I said that, yeah, there was a question that why the map total only 3, should it be 4, since the input file is split into 4. Again, as I said, Mr. Sudhakar, that's not something at a map level. It goes with the best recommended partition that it does internally. So again, you cannot guarantee the number of maps. That's the specific thing which it mentioned. The only thing that you guarantee is the number of reduce which you mentioned. But when in case of a map, it tries to take the best capacity. In this case, all these 3 maps are running on the single box itself. Now, had I have 4 different servers added here, there was a good possibility that it creates and try to run it on that particular thing itself. So this is where it will put in that your map, when you it reads the data. It has these input splits happening depending upon the overall size, and then it tries to run. And in this case, all the 4 blocks are on the same machine, and these 3 maps, they are running, taking the individual blocks, and when one map finishes up, then another I'll say instance of map starts, which takes the 4th instance in place. So again, with map you cannot guarantee that number itself, so it's not the direct math itself, but with reduce you definitely can. So in this case, if you just try to, now suppose let's try to run this, and this time we'll just have, take a look, word count data. Let me see, I think there is just one specific thing. Just give me 1 minute.